In this lesson, we will be looking at the inverse trig functions and their relationships with the right triangle trig that we looked at earlier. Now let's remember the basic setup that we had in right triangle trig. We have a reference angle, and in respect to that reference angle, we have three sides. We have our opposite side, we have our adjacent side, and we have the hypotenuse. And the hypotenuse is always the side opposite the right angle. And the three relationships we had for trig was that sine is related to the opposite and the hypotenuse. Cosine is related to the adjacent and the hypotenuse. And tangent is related to the opposite and the adjacent. So looking at this example, we have our reference angle, which is x, and we are given the adjacent side of 8 centimeters and the hypotenuse of 12.5 centimeters. So when you have adjacent and hypotenuse, that tells us that we're dealing with cosine. So the cosine of the angle is equal to the adjacent side over the hypotenuse. So that means we have the cosine of whatever the angle x is equal to the adjacent side, which is 8 centimeters, over the hypotenuse, which is 12.5 centimeters. So how do we go about finding the measure of this angle A? Well, to do that, that's where our trig functions are going to come into play. We have an inverse cosine function, and it's going to look like cosine raised to the -1 power. And the nice thing about inverse functions is when you take the inverse of the corresponding function, they cancel each other out. So if we take the inverse cosine of the normal cosine of x, and we do the same thing on the right side, we take the inverse cosine of this ratio. On the left side, everything kind of cancels out, and we're just left with x. So in this case, x equals the inverse cosine of 8 over 12.5. Now we can enter this into our calculator. And the first thing we want to make sure is that the mode is set to degrees. So click on the mode button and make sure it's set to degree instead of radians. And so to compute the inverse cosine is second and cosine. So we'll press second and cosine, and that gives us cosine to the -1 power there. So the inverse cosine of 8 divided by 12.5 is 50.208, or if we rounded it to 2 decimals, it would be 50.21. So the measure of this reference angle x is 50.21 degrees. And since this angle is the measurement from the horizontal up to our hypotenuse, we actually can refer to this as the angle of elevation. Let's look at another example. Okay, in this example, our reference angle is actually up here. And so from that particular angle, we have this measurement of 33 millimeters, and that is actually the opposite side. And we still have a hypotenuse here, which is 47 millimeters. And so the relationship that we had relating opposite and hypotenuse is sine. And so we know that the sine of the measure of our angle is equal to the opposite divided by the hypotenuse. And if we plug our numbers in there, we have the sine of the measure x equals the opposite, which is 33, divided by the hypotenuse, which is 47. And again, to cancel out the sine to get x by itself, we can take the inverse sine of both sides. So on the left side they cancel, and we're left with x is equal to the inverse sine of 33 over 47. And again, we can compute that on our calculator. This time make sure you use the inverse sine button. So if we compute this on our calculator, we'll get that the measure of this angle is 44.60 degrees. And let's look at one more example. In this last example, notice that the measure we're looking for, the angle we're looking for, is this angle outside. And there's two ways we can go about doing that. One is we could try and figure out the measure of this angle here first and use the fact that this is a right angle. Or we could use another property of geometry that would tell us that the measure of angle x up here is the same as the measure of the interior angle down here. And so this will be the easiest. Let's just use this property, that this exterior angle here is equal to the interior angle here. And so if we look at this is my reference angle, and the sides I have from there is the opposite and the adjacent. So which trig function deals with opposite and adjacent? And that's tangent. So again, we know that the tangent of our angle x will be equal to the opposite over the adjacent. And so that means that the tangent of x will be equal to 24 over 35. Again, we have an inverse tangent function that allows us to take the inverse tangent of both sides. And when we do that, the inverse tangent and the tangent cancel out, leaving with just an x. So x equals the inverse tangent of 24 over 35. And if we compute that, we get that x equals 34.44 degrees.